Assalamualaikum and hi to everyone. Thank you for joining our meeting session today. I hope you guys in a good condition although we are in this pandemic season. So today, I'm IKHWAN bin AZRI, manager of Lajak Laku Sendirian Berhad, want you guys to present to me your latest job that I give to you last week, which is about monitoring the quality of tablet production for Lajak Kurus I tablet. First of all, I want you guys to describe and summarize the sample data of your assign, which is Lajak Kurus I tablet produced in December 2020. So who will start first?
Okay, I will start first, sir. I am ZAFRI from the team. Since for the summarization of the production of our tablet in December 2020, we got 200 samples of tablet that have been categorized into 3 times which the tablets were produced, which is the morning shift, evening shift, and night shift. And we categorize it in the form of weight, relative density, and tensile strength. And we decided to summarize it in the tabular form, graphical form, and numerical form. For the weight, we have sum all of the weight for the all the weight of the tablets from according to the shift, which is in the morning we have 20,006.94 mg, evening we have 27,309.51 mg, and for the night shift we have 22,684.96 mg. That makes the sum of weight is 70,001.41 mg. Not only that, we have total relative density same according to the shift, which is for the morning, evening, and night shift, which is the 5,018.7%, 6,884.8%, and 5,701.2% respectively, which means the sum of all the relative density is 7,604.7%. After that, we calculated the sum of tensile strength by their shift too, and the sum of the tensile strength for all shift, we sum all of them, we managed to get 1,419.1 MPa. And based on our summarization, we can conclude that if our evening shift produce the highest number of tablets, which is 78 tablets, and the highest data for the weight is in the range of 342.99 mg to 352.98 mg, which is it contains 54 data. And based on, we can see in the table form, like I said, I said to you that we have the total weight, total relative density, total tensile strength, and we have categorized it in follow the range of the weights. And there's the row labels and count, and we have produced you the graphical bar graph that show that our highest range of weight is within 342.99 until 352.98. which is with the count 54. And that's all for the summarization of data. Thank you, sir.
Thank you, Muhammad ZAFRI. So next, as we know, the Food and Drug Administration (FDA) authority requires that weight of standard tablet produced by manufacturers should be normally distributed with 350 mg with standard deviation of 14 mg. So can anyone comment on whether there is significant evidence that Lajak Kurus I tablet produced in December 2020 do follow this distribution?
Hello, sir. I would like to present about this question. Firstly, we need to determine. My name is Muhammad Adam. I'm from the team also. So we need to determine whether the data follows normal distribution with a mean of 350 milligram and standard deviation of 14 milligram. We assume that degree of significance, that is alpha, is 0.05. So we decided to use goodness of fit test, as the test is suitable to test whether certain data follows or obeys certain distribution. After constructing and analyzing the tabular forms of the data, we can see that the data are focused on a single subscript data, which is the tablet's weight. Hence, we can determine the claim as follows. For the first of all, hypothesis statement. Our H note is the weights of standard tablets produced by manufacturers follows normal distribution. And for the H1, the weights of standard tablets produced by manufacturers does not follow normal distribution. We move to the second one, that is statistics test. For this test, as you can see, there are two tables. This table above consists of the tablet's weight, observed data, that is OI, probability of hash not true, that is PZ, expected value, EI, and the chi-square summation. There are two data with EI less than 5, which is for raw labels 312.99 to 322.98 and 382.99 to 392.98. So we need to merge the data with the closest data. If we sum up the chi-square summation, we will get the value of chi-square test value, that is 0.4685. Okay, next, for the third one, rejection rule region. Based on the chi-square graph, we can get the value of chi-square test at the border of reject hash node. As you can see, the formula is alpha k minus p and minus 1 is based on the statistic test. We can obtain the value of k, that is amount of data, equal to 6, and p, amount of estimated unknown, equal to 0. Therefore, we will get the critical value from the chi-square graph, that is 11.0705. Therefore, since our chi-square test is 0.4685 is less than our critical value from the graph, that is 11.0705, we accept hash node, or we can say we fail to reject hash node. Thus, the weights of standard tablets produced by manufacturers follow normal distribution with mean of 350 mg and standard deviation of 15 mg. That's all.
Okay, thank you, Muhammad Adam Jamal. So next, as we know, we have many production in different shifts, which is morning, evening, and night. So I want someone to comment on whether there is any significant difference between tablet weight from the different shifts, which is morning, evening, and night. Can someone?
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is
Sure.
Muhammad Adam. For the question C, from our monitoring of our tablet production, we are needed to give our comment about whether there exists a significant difference between tablet weights obtained from different shifts. As given in the Excel's data, there exists 3 shifts altogether, which are morning, evening, and night. Therefore, we are required to use one-way analysis of variance, which is ANOVA, to analyze our data, since there are more than 2 levels of factors shifts. To start our analysis, first we need to set the hypothesis statement, which are H naught. There is no significant difference between tablet and weights from different shifts. And H1, there is a significant difference between tablet and weights from different shifts. So we assume the level of significance alpha value is assumed to be 0.05. Then we will proceed with the data analysis using the raw data from the tablet production. Therefore, we can use Microsoft Excel to help us with the data analysis efficiently. The data is then sorted and arranged based on 3 main columns, which are morning, evening, and night respectively. Next, we can use the built-in function in the Excel, which is ANOVA single factor. After completing the value needed, the table will tell us the p-value for our set of data. The p-value is then compared with our chosen level of significance, which is alpha equals to 0.05. There are 2 cases for our result, which are if the p-value is larger than A alpha, then we accept H naught. The second is if the p-value is lesser than alpha, then we reject H naught. So based on our ANOVA table, the p-value that we gain from the data is 0.74 3087, which is higher than our assumption value of significant level, which is alpha equals to 0.05. Thus, we accept H0 and we can conclude that there is absolutely no significant difference between tablets and weights from the different shifts. So that's all from me. Thank you.
Okay, thank you, Mama Adam Azman. So, last but not least, tablet hardness can be represented by its relative density and tensile strength. Studies have indicated that its tensile strength depends on the relative density regardless of production shift. So recently, a batch was found to produce cluster of tablet that show low relative density value of 68%, 74.3%, and 80.1%. So based on your current data in December 2020, what is the prediction of the tensile strength for such tablet? So I need someone to comment on the validity of the model that you have used to carry out this prediction.
Okay, thank you for your question. My name is Muhammad Imran, and for your answer, the linear regression equation was chosen as the model to predict the pill's tensile strength. Before predicting the tensile strength, we use Excel to perform regression and correlation analysis to see if there was a linear relationship between relative density and the pill's tensile strength. The sample correlation coefficient is nearly 1, indicating a strong positive linear relationship. Following that, we estimated the significance f to compare with the significance level from the ANOVA table. And from the ANOVA table, we know that significant f is less than 0.05, which is significant level alpha. Thus, we reject H node. As a result, the linear regression model has significant evidence of linearity. Using a simple linear regression equation, we can predict the tensile strength of tablets. The data from linear regression equation is then obtained using Excel analytical models. The following is the linear regression equation that was discovered is y equals to 0.277934125 plus 0.077451656x, and we can predict tensile strength based on relative density using this linear regression equation. The estimated tensile strength for relative densities of 68%, 74.3%, and 80.1% is 5.544646733 megapascal, 6.03259, 2166 megapascal, and the last one is 6.48181177 megapascal respectively. To sum up, linear regression is a valid and appropriate model for predicting a pill's tensile strength based on its relative density with up to 95% accuracy. Thank you.
Thank you, Muhammad Imran. So I think that's enough for today. Good job everyone for the presentation. I'm honestly really impressed with you guys. Thank you so much for a very interesting and nice presentation. I think we should have dinner together after all this pandemic ended. Why not? Don't worry, I will pay for the dinner. So I think that's enough for today's meeting station. Take care everyone. See you next time. Assalamualaikum and thank you.